Benzoin condensation is the condensation of two molecules of benzaldehyde in the presence of cyanide to give benzoin. In this video, we'll talk about the chemical reaction and its mechanism. So let's begin. The reaction involves the condensation of two molecules of benzaldehyde in the presence of sodium cyanide or potassium cyanide in ethanol to produce benzoin. This reaction is very interesting. As you can see that we do not have any other reactant. We have only two molecules of benzaldehyde condensing together, and it somehow defies the concept of a nucleophile reacting with an electrophile, because you can see that we have the formation of this bond between two carbons which were initially the carbonyl carbon of both the aldehydes, both the benzaldehyde molecules. And you know that the carbonyl carbon is electrophilic in nature. So actually this is the bond formation between two electrophilic benzaldehyde carbonyl carbons. How does this happen? Is it really the bond formation between two electrophiles, or there's something else happening? We will see this in the mechanism that follows. So to start off, this benzaldehyde molecule is attacked by the cyanide. The cyanide ion here acts as a nucleophile, so it will definitely attack the carbonyl carbon, which is electrophilic in nature, producing this oxyanion, which then abstracts proton from water to produce cyanohydrin. With the release of hydroxyl ion here, let me write this cyanide in this form. This hydroxyl ion that is released in the solution then abstracts this proton here, which shifts this electron density between the two carbons here, and that shifts the electrons towards nitrogen. And now you can see that we have the formation of another ion here, which looks like this. Here we have a negative charge on the nitrogen, and because this is quite unstable and it has double bond in the vicinity next to it, so this negative charge can be shared between carbon and nitrogen to restore the nitrile group, which will shift this pi bond towards this nitrogen, towards this carbon here, and that will increase the electron density on this carbon. Now remember that this carbon here is actually the same carbon which was initially the carbonyl carbon of benzaldehyde. And at the start, while it was electrophilic in nature, here, because of this transformation, now it is going to be nucleophilic in nature. So what we have done with the help of this cyanide group is that we have reversed the polarity of this carbon, which was initially electrophilic, but now it is going to act like a nucleophile. And this reversal of polarity is known as Umpolung. So benzoin condensation is a very good example of Umpolung, or in other words, the reversal of polarity. So we have reversed the polarity of this carbonyl carbon, and now it is acting as a nucleophile, and you can now sense what is going to happen next is that this nucleophile can easily attack the electrophilic carbonyl carbon of the second benzaldehyde molecule. So this anion collapses back, forming the nitrile group, which shifts this electron density towards the carbon, and then that carbon attacks the carbonyl carbon of the second benzaldehyde molecule. So what we have now as a result is the formation of this species here. So we have this oxyanion, and here it is attached to this carbon here. So we draw another carbon here, and this OH is here. And now we have a carbon-carbon single bond here, and a nitrile group is restored. And then we have another benzene ring here. This oxyanion will take up a proton from water to form an alcohol, with the release of this hydroxyl. This hydroxyl then abstracts a proton from this oxygen, restoring the carbonyl with the release of this cyanide group. And what we have as a result now is the formation of benzoin, which looks like this. A ketone is produced here, and so we have the formation of benzoin. So this is how benzoin is produced by the condensation of two molecules of benzaldehyde in the presence of sodium cyanide. Stay tuned for more named reactions in organic chemistry. See you later. Thank you so much.